Some strange results have come up in about the last 20, 30 years, particularly in astronomy and also in quantum physics, which suggests that the universe actually may have a purpose, and some physicists are now suggesting it does have a purpose. And this has come out of some findings about some of the fundamental numbers in atomic physics.
During the past 40 years, scientists have determined the relative strengths of each of these primary laws and forces. These strengths are so critically balanced, they are often described as being finely tuned.
These are numbers like the mass, the weight of an electron, the weight of a quark, the strength of gravity, the strength of the electromagnetic field. About 20 numbers that describe those and other parameters, features of our world, but nobody knows why it is that those numbers have the particular values that they do. Now, you could easily say, yeah, who really cares? You change the mass of the electron by a little bit more, a little bit less. Does it really matter? And the answer is it does. See, it turns out that if you imagine that we had 20 dials right here, and we could fiddle with those 20 numbers at will, even a small change to the values of the known values of those numbers would cause the world as we know it to disappear.
Because it turns out, and this is a very surprising, unexpected discovery, that the laws of physics, the basic given fabric of the world, had to be very specific, very finely tuned, as we sometimes say, for the possibility of carbon-based life appearing at all.
For example, the strengths of the other forces are all important, the masses of the various subatomic particles. Now, this is one of a long list of properties in underlying physics that seem to be prerequisites for a universe with life. If all of these things were even a little bit different, then life, certainly life as we know it, could not exist.
It's a very surprising conclusion, but it's true, and all scientists will acknowledge that's the case.
Bernard Carr is a cosmologist and studies how the laws of physics operate in the universe. He says that the laws of nature are so finely tuned to enable complex life to exist that it is extremely unlikely that this could have happened by chance. Such fine-tuning, Carr believes, at least raises the possibility of a tuner.
This is a diagram, it's called the pyramid of complexity, and what we've got here, we've got the different levels of structure in the universe, and at the bottom we've got the things like quarks that make up the atoms, and the atoms build up to make molecules, the molecules build up to make living cells, the cells make organisms, and eventually we end up with brains and consciousness. It's rather hard to estimate what the probability is, but it was clearly very, very unlikely that those fine-tunings which allowed this pyramid of complexity to arise would be there.
A very simple and central example is the question of where does carbon come from? The very early universe doesn't make any carbon. It's very simple, it only makes simple things. Hydrogen and helium, and they're pretty boring in terms of chemistry. Now, where does carbon come from? There's only one place in the whole universe where carbon is made, and it's in the interior nuclear furnaces of the stars. We are people of stardust, made of the ashes of dead stars. And it turns out that the process by which carbon is made inside the stars is an extraordinarily delicate process. In fact, it looked at first sight as though it couldn't happen at all. It's only possible because there's a very large enhancement effect, called a resonance in the trade, which makes it go much quicker than we might have expected. And that resonance is there because the laws of nuclear physics take a very specific form. If they were a little bit different, either there would be no resonance or it would be in the wrong place at the wrong energy. That's a very striking example of how finely tuned the universe has to be for us to be inhabitants of it.
The fine-tunings, how fine-tuned are they? Most of them are 1% sort of things. In other words, if a thing is 1% different, everything is bad. And a physicist could say, maybe those are just luck. On the other hand, this cosmological constant is tuned to 1 part and 10 to the 120, 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident. That's the most extreme example of fine-tuning.
No force in the history of cosmology has ever been discovered to be that finely tuned. The cosmological constant needs to be set to 1 part in a trillion, 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 trillion Otherwise the universe would be so drastically different that it would be impossible for us to evolve. That the cosmological constant arrived at such a tiny value by chance seemed to be out of the question.
Ils sont nombreux à dire que finalement, quand on regarde l'univers, surtout à l'origine, eh bien, on constate qu'il ne peut pas être né par hasard, et que le hasard n'a aucun rôle, et que plus on remonte loin dans le temps, donc plus on remonte vers le Big Bang, plus on trouve un univers qui est ordonné, réglé, ajusté.
For example, if we go back to say 1 second after the Big Bang, at that point the expansion rate and the mass density have to have been adjusted to each other just right, so that the universe is just at this critical point. If the universe at that point were expanding just 1 part in the 15th decimal place faster, the universe would have flown apart without galaxies ever having had a chance to form. On the other hand, if the expansion rate were just a little slower than what we think by one change of 1 in the 15th decimal place, then the universe would in fact have expanded to a maximum size and collapsed. We would never have even reached the time in the universe at which we're living.
Alors, ajuster comment? Eh bien, il existe ce qu'on appelle des paramètres cosmologiques. Ce sont des grandes constantes, la constante de la vitesse de la lumière, par exemple, qui fait 300 000 km à la seconde, 7 fois donc le tour de la Terre en 1 seconde. Il y a la constante de gravitation. Ce sont des chiffres, des données chiffrées, avec un zéro, une virgule, et puis parfois des dizaines de décimales derrière la virgule. Eh bien, si on changeait simplement une seule de ces décimales sur une seule de ces 20 constantes, l'univers ne pourrait pas apparaître. Eh bien ça signifie que le hasard n'a aucun rôle à jouer à l'origine de l'univers.
How did this come about, this rather terrific luck?
Of course, one of the first explanations that comes to mind is that there was a tuner or a creator, or if you like, God. And obviously for people of a theological disposition, the idea that the fine-tuning is evidence of God, of course, is wonderful.
But let me come now to the grand design, because like every other physicist, Hawking is confronted with powerful evidence of design in the fine-tuning of the universe. He explains, our universe and its laws appear to have a design that both is tailor-made to support us, and if we are to exist, leaves little room for alteration. That is not easily explained, and raises the natural question of why it is that way. The discovery relatively recently of the extreme fine-tuning of so many of the laws of nature could lead at least some of us back to the old idea that this grand design is the work of some grand designer. That is not the answer of modern science. Our universe seems to be one of many, each with different laws. Now, the idea of a grand designer is certainly old, but the important question to ask is whether or not it is true. Simply to say it is old can give the erroneous impression that what is old is necessarily false and has been superseded. Secondly, it can give the further erroneous impression that no one holds it today. But some of the finest minds in science, at least one Nobel Prize winner in physics, does hold it. The conviction that there is a grand designer is one of the major convictions in the history of human thought. That does not, of course, prove it's true, but it certainly means it's worthy of our serious consideration. Now, Hawking goes therefore too far in saying that is not the answer of modern science. There are scientists who believe it, there are scientists who do not. But his answer is what he calls the multiverse.